Salafalava and welcome back. HP Photon Tutoring here. Ile kako video nei o le whailoa tuai pe whawheona e suea le voltage o le current ma le resistance ni ko kongo le parallel circuit. In this video, I'll show you how to calculate the voltage, the current, and the resistance in a parallel circuit. What is a parallel circuit? In a parallel circuit, all components are connected across each other. It means resistors are connected in different branches. No vinga ese the current alu lesi resistor, ese the current alu lesi resistor, ese for the current alu lesi resistor. For a current in a parallel circuit, the total current from the battery splits. No vinga the current or the total current is shared among different resistors for different branches. So the current in each branch can be different. And the form says IT is equal to I1. I1 means the current across the resistor 1 plus I2, current across the resistor 2, plus I3, current across the resistor 3. Resistor connected in parallel. For the voltage in a parallel circuit, the voltage is identical across every branch. It means same voltage. So whatever input volt, that's the same voltage on the resistor or connect in parallel. In the form VT is equal to V1 is equal to V2 is equal to V3. V1 is the voltage across the resistor 1. If it's parallel with the resistor 2, then it's same voltage. So V2 is the same as V1. V3 in a parallel circuit for V1 and V2. For the resistance, when you add many resistors, it will result in a less total resistance. Lalo binga lefa makalanga ay kilo kako formula fa mai 1 over RT longa winga wala kalango ay le fapoponga o inverse o kako resistor. So 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. No winga, the sum of the total resistance is less. For my use the diagram below to answer the following question. So this is a very simple parallel circuit. Three resistors are connected parallel to each other. So resistor 1 is in parallel with resistor 2, in parallel with resistor 3. The first question, calculate the total resistance. So to find the total resistance, mankwe still the Ohm's law relationship, where B is equal to I multiplied by R. BT, total voltage, is equal to IT multiplied by RT. IT is the total current and RT is the total resistance. So to find the RT, the total resistance, formula is 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So it's a 4 resistor in parallel, no continue expression left plus 1 over R4. But our diagram is only 3 resistors. Now sub in the values, 1 over R3 plus 1 over 4 plus 1 over 2. Yeah, simple additions of fractions. You can continue with the cross multiplication. When you do the cross multiplication for the first two fractions, 1 over 3 plus 1 over 4, mawailo 7 over 12. Now, we have 4, 1, 4, 3, 1, 3, 4 plus 3 is 7, and then the product of 3 and 4 is 12, plus 1 over 2. When you continue with this one, mawailo 26 over 24. Remember, this is 1 over RT, and we are looking for RT. So how do we get RT? Reciprocal expression. When we do the reciprocal for RT divided by 1, RT, and reciprocal is equal sign 24 divided by 26. Now RT is equal to 24 divided by 26 is equal to 0.26. 0.92. So this is the total resistance in the circuits, 0.92. Then if I made kako rule level umatu, I can add resistor in parallel and result in a less amount of resistance. You see, 3 plus 4 plus 2 in parallel circuits is equal to 0.92 ohms. Second part of the silly, or the FCD my ilekako total current. And total current, IT, when you derive this form, making IT the subject here is equal to VT, total input volt divided by RT. When VT is 12 divided by RT of 0.92, IT is equal to 13.04. So in one decimal place, 13.0 ampere. So this is the total input current. And then the last question is asking for the current and the voltage across each resistor. So like all I saw more about it, length of information about the voltage in a parallel circuit is the same voltage. Longa winga ava per input voltage 12, longa winga or the 12 volts anga lela alu kongole R1 12 volts ni kakoa, R2 12 volts for the kakoa, R3 because the information ange for the voltage in a parallel circuit is the same voltage. Now winga venga appear B1 is equal to 12 volt, B2 is equal to 12 volt, and B3 is equal to 12 volt. For the current like a Congo parallel circuit, a share the total current. We know 13.0 ampere is the total current in this parallel circuit. So this 13.0 ampere is shared among R1, R2, and R3, resistor 1, resistor 2, and resistor 3. If I fail lang a share the current layer of 13, ikako resistor is equal. A share for it depend on the resistance. No, we have if I pair I1, which is the current across the resistor 1, is equal to B1, the voltage across the resistor 1, divided by R1, resistor 1. So what is the voltage across the resistor 1? 12 divided by R1 of 3, and I1 is equal to 4 ampere. Longa winga from the 13 total current, only 4 amperes the current la yalu ile resistor 1. And for I2 is equal to V2 over R2, and we know that V2 is the same as V1, which is 12 volt divided by the resistor 1 is 4 ohms, and it's 3 ampere. Yeah, I3 or the current across the resistor 3, 12 volt V3 over R3, and it's 12 volts, same voltage, divided by 2, and the answer is 6 ampere. So remember, 13 ampere is the total current. It's shared among the 3 different resistors. Now we get I1 is 4 ampere, I2 is 3 ampere, and I3 is 6 ampere. When you sum all these I1, I2, and I3, the answer is 13. That makes sense. That formula, IT is equal to the sum of I1, I2, and I3. So 6 plus 3 is 9, 9 plus 4, 13 ampere. So the current is shared among the resistor in a parallel circuit, but the voltage is the same. All resistor all parallel circuit. So let's make our remember in series, I can learn resistance, I can learn for ile voltage, but in parallel, I can learn resistance, ela ikikile current. So for example, the highest resistance like R2, which is 4 ohms, and the amount of the current is only 3 ampere. Compared to the lowest resistance, which is 2 ohms, and the current is 6 ampere. And that's all for this lesson. Mankua a peisa fasili ku umaila comment ilalo kako video lea, like ni the video ma subscribe kako channel ia ma share kule information lea po ai lava mga umbia le sesuangi kako parallel circuits. In our next video, the afaya ko a combination of a series circuits male parallel circuits. Yeah, for mata mai, God bless. HP photon, one photon at a time.